Hello all, thank you for joining us today. I'm Krishnan Srinivasan here. Very glad to welcome you all as we dive into one of the most exciting announcements from Snowflake Summit 2025, which is the launch of Snowflake Openflow. So, announced at the summit earlier this year, Openflow makes a significant step towards how we design and orchestrate intelligent workflows directly within the Snowflake platform. It brings together data, AI, and operational logic to help businesses automate complex processes and drive faster, smarter decisions, all in a governed and secured environment. So, about today's session, it is kind of meant to familiarize us with the key features of OpenFlow, explore its potential applications, and kind of begin a conversation on how we can start leveraging it with our own data and AI initiatives. So, we have our Cittabase team here who's going to walk through all of these features as we go through this call. So, with that, I'll hand it over to Indu, who will guide us through the agenda and then the core capabilities of OpenFlow, and then the others will follow as well. So over to you, Indu.
Thanks, Krishna. Hi all, this is Indu here. So, thanks, Krishna, for the good introduction. So, we'll just see what is the main agenda for this webinar. In this webinar, we'll focus on the core features of Openflow, the infrastructure that is required to set this up, its core components, the various business use cases, and a demonstration on how Openflow can be used to ingest streaming data using a Kafka connector. This webinar aims to showcase how Openflow revolutionizes data movement and makes the data ready for actionable reporting or AI applications, all within the Snowflake platform. So the basic question, what is Snowflake Openflow, right? So it is the new data integration service designed to simplify data movement between various sources and destinations within the Snowflake ecosystem. It's a managed service built on Apache NiFi, offering capabilities for both structured and unstructured data in both batch and streaming modes. It allows users to design and manage data pipelines without relying on third-party tools like Fivetran, Matillion, Informatica, etc. It enables users to ingest unstructured data from various data sources like Google Drive, SharePoint, Box for AI applications, or replicate change data capture from databases like SQL Server for more actionable insights. This slide is just a pictorial summarization of what we discussed in the previous slide. Openflow leverages the robust capabilities of Apache NiFi, known for its scalability, handling of diverse data formats, and strong security features. It can either be deployed in customers' VPC or in Snowpark container services. As of recent announcements, Openflow is generally available in all AWS commercial regions with BYOC deployment. So what's a deployment? A deployment is where your data flows execute. It can have multiple runtimes to isolate different projects or teams. A runtime hosts data pipelines and uses OAuth 2 authentication to Snowflake. You can deploy pre-built connectors or build new pipelines using the hundreds of processors and controllers offered by Openflow. It has several pre-built connectors, including SaaS connectors, such as LinkedIn Ads, database connectors, such as SQL Server connector, streaming connectors, such as Kafka, unstructured connectors, such as Google Drive or Box, aiming to provide a unified user experience. The control plane is a layer which contains all components used to manage the Openflow. Let's now deep dive into what are the key features of Openflow. The first one is it is open and extensible, which means apart from the pre-built connectors that are available, Openflow allows you to build and extend processes according to your requirements. It is a unified data integration platform, which means it enables data engineers to build and manage data pipelines using customers' VPC or Snowflake managed VPC, all within the Snowflake ecosystem. It is enterprise ready, which means it automatically inherits Snowflake's native security and compliance standards, ensuring trusted and secure data integration. It offers high-speed ingestion of all types of data in both batch and streaming modes. It also enables continuous ingestion of unstructured data so that users can instantly start interacting with the data for AI-driven applications. Now, my partner Dinesh Babu will be walking you through in detail about the two deployment methods available, various AWS services that are created, and also the core components of Openflow. Over to you, Dinesh.
Thank you, Indu. So now let us see what is the infrastructure required to deploy and host the Openflow. So Snowflake offers an hybrid deployment method, giving the developers flexibility in where the pipeline runs. It offers two methods. One is Snowflake hosted, where everything is handled by Snowflake within Snowflake. And the second method is bring your own cloud. In this method, we get to choose our cloud service of our choice. So currently, the Openflow can be deployed only in AWS, that is in GA, while the Snowflake managed services and deployment to other cloud services are not available yet. So moving on to the next slide. Let's delve into the AWS services which is required to deploy and host the Openflow. So Snowflake actually provides us a YML file which can be used in cloud formation template, which will spin up the services which is required for the Openflow, which includes a creation of VPC with public private subnets, NAT gateway, elastic IPs for the private connectivity of Snowflake, then an Snowflake OAuth secret, an S3 bucket for the out to store the logs and output of a Openflow agent, and EC2 instant connection endpoint where the Openflow agent can continuously communicate and look for the deployment upgrade. And also it has a Kubernetes cluster which has node groups, load balancers to handle the auto scaling, and it spins up 3 EC2 instances. One instance for the Openflow agent, which installs Openflow in a VPC and it handles the runtime. Second instance is for the management. It acts as one of the Kubernetes engine as an operator to run the other core softwares. And third one will be based on the runtime, which we set up in Snowflake. Based on that, an instance will be triggered. So these are the AWS services which are getting spinned up when we host and run Openflow in AWS. So when moving to the next slide, coming to the Openflow core components. So using the core components, we can drag and drop and start building the process flow. So core components of Openflow are the processor, input output port, process group, funnel, registry, and label. So processor is executes a specific task like data ingestion, transformation, like storing data from the sources, doing the transformation, and sending the data to the destination. So input and output port is to handle the data between multiple processors. Let's say moving the data from one process to another process, between process group, even between NiFi instances. Process group is like a directory. We can build a specific workspace for a specific use case, like putting together similar set of processor in a single group together. Funnel is to merge multiple sources into a single flow. Let's say you are handling multiple sources in a flow that has to be combined and merged together. Funnel can make use of that. So coming to registry, registry is used to version control the flow files in Openflow. With help of this, we can implement CI/CD in Openflow, and with the version control, we can share the same object with different NiFi instance. Coming to the label, we can just add comments to the Openflow flows processor. Let's say what the processor does, how it has to be managed. When compared to stored procedures, it's like adding a comment to the code saying what this code does and when was this code change done, and to track all those changes. So these are the major Openflow core components. Next, Azar will be showing a demo on Kafka using this Openflow core components. Over to you, Azar.
Thank you, Dinesh. Thank you for putting out all the building blocks of Openflow very clearly for the audience here. So before we get on to the demo, let me just quickly give an overview of what Kafka actually is and what are the streaming data sources that can be used with Openflow and how it is being handled. So as a basic idea of streaming data source, it's like imagine that as a messaging service or a transaction messaging service that gives out some messages in a very short period of time. For example, let's say that you get 15 or 20 messages per second. So all these messages will be streamed from a data source into Snowflake through different streaming data processes. such are the processor are Apache Kafka, Confluent Cloud, and it can also be an IoT device which records the temperature of your room or a specific place, and then sends the temperature recorded to a different source or solution. Most of these messages will be JSON formatted, and what we would the typical movement of these messages would be having multiple data pipelines to read the messages, to unpack it into a structured data, and then storing them into our structured tables, DW layers, and raw layers. And Openflow is a game changer that is seamlessly integrating all these processes into one indefinite pipeline that is unpacking the JSON and then loading the tables, and also like maintaining the schema changes seamlessly. So this is about the overview of what we are going to show now, what we're going to see now. So let me just quickly share my screen and get on to the demo part. Okay, so okay. So when Dinesh Babu explained about what are all the instances that the BYOC, bring your own cloud AWS spins up. So these are the three instances that are mainly are the building pillars of Openflow, which is hosted in Snowflake. So what we need to do first is we just need to run them and keep them running before we start anything with the Openflow part. So let me just quickly show you where we can find the Openflow on the Snowflake UI. If you go to your data pane, you could see there is a simple thing called Openflow here. So you just need to click that and click on Launch Openflow. That will bring us to this screen where you can see multiple connectors, and also these are the two main things about the deployment. So this deployment is what that has been hosted on the AWS part, and within a single deployment you can have multiple runtimes. Imagine this as a compute engine of your Openflow, and this as your worksheets where you have your code or where you have your pipelines running. So for now we have a specific runtime which is up and running. And I'll just quickly explain you about the connectors which we have here. So there are multiple connectors as we have emphasized. So we have structured data connectors, unstructured data connectors, PDF connectors, and all others. So for now, as far as this demo is considered, we are just going to see into the Apache Kafka JSON data format connector. So what we have to do is just click on Add to Runtime and select the runtime that we are going to use. For this demo, I'm going to use the Cittabase partner runtime here, and I'm just going to click add. Once that is added, this is how the screen would look like. You can see all the different icons here on the top, which is already Dinesh explained what's the process group and what are all the input and output ports here. Once that connector is added, this is how the outlook would be. So for every connector, the pipeline, the source and target stays the same, right? Like here we have the source for us is the Apache Kafka that is running, the streaming solution that is running, and the target is Snowflake tables. So we just need to configure the connection string for them to authenticate and load the data. So that can be done on the parameters section up here. So once you click the parameters, you could see different parameters that we have to input the data into. So for example, we have destination database, that is like the end database that we are going to load the data, and we have schemas. And if it's like an iceberg enabled, we can click that as true or false. That depends on the business use case. And also there are like different security protocols. For this demo, we are using the Confluent Ingestion Kafka stream that is generating you the data of a specific customer order, like it's a dummy data that we are using here. And for that, the authentication type might be different. For here, we are using the SASL SSL authentication type, which works with an username and password combination to authenticate the Kafka thing that we are producing on the Confluent side. And also on the destination part, the Snowflake part, it's not that it should be in the same account. You can also ingest the data into a different account, and the authentication part for that specific destination can be a private key authentication part, which makes it much more secure and being in control of the Snowflake horizon. So that is about the parameter context, setting up the connection string for the Apache, for the Kafka to load the data into Snowflake. Okay, let me just quickly explain like what the process group is. So a process group, consider this as like your whole pipeline as a root folder, and then when you click into that, you will get multiple process groups that can be considered as subfolders inside a root folder. So here you have this is the starting point of this process group consumed from Kafka. So the messages that we are receiving from the Confluent is being consumed from Kafka, consumed from there, and then we have specific things that are mapping to the Snowflake table. We have map a topic to the table. A topic is considered them as a business process that is sending you the message. For our case, it's the customer orders, right? So the customer order is considered as a topic. So we are mapping the customer orders topic to a specific table in Snowflake. That's what the mapping topic to table does. And the second process here is like create table if not exist. So if a customer orders table is not, it's not a pre-configured table, right? What the Apache, what the Openflow would do is it will create a table with the comparatively to the message that it receives. That's the create table if not exist. And then we have the evolve schema process. So whenever we deal with unstructured data, the one of the biggest pain points that we see is like the schemas keeping on evolving, right? And then we have to when we convert the unstructured data to a structured data, we had to compensate that evolving schema to alter the tables, and then alter the tables and the downstream process everywhere. But here, Snowflake Openflow handles the schema evolution very intelligently, that it itself adds another column, or like adds another column for any changes on the messages. And finally, we have put data to Snowflake. This is where we will load the data, the unpacked JSON data or the unpacked message that we're getting from the Confluent into the Snowflake table. So before we start this process, let me just show you a quick overview on how the table now currently looks like. So this is the table that we have, the customer orders. And as you can see that there are about 1, 2, 4, 3, 4, 6. So this is the total count that we have. These are the total count of messages that we have here. So you see like the JSON format which we have here, which we are receiving as a message here, that has been directly converted into a structured data up here. We have order ID, item ID, units, and then the metadata of that specific message. So this is how the customer orders look like before we start the ingestion. Now let's get back to Openflow and start the ingestion process. So as you can see that it has been stopped. Now all I need to do is just click start here. And now you can check here that the total number of messages that has been sent is about, let me just quickly refresh to get the current data here. It's about 223 and 335, right? So that's the total record that we have. And on the Openflow, so you can see that the out parameter, which says that there are a lot of data that has been ingested, and the same goes on with all the other process groups here. So let me just quickly query the table and see like how many records that are being ingested right now. So now, as you can see here, there is an increase in this number, and the messages that has not been ingested while we have paused the process has also been ingested now. And when the process group runs continuously, whatever message we receive here will automatically be reflected over there. The latency is very low. We could term it as near real time data ingestion, but it can also be made faster than what we have right now here. So this is about the Openflow thing. I'm just going to stop my screen sharing and
I hope you're able to see my screen.
Yes.
Yeah.
Before I begin, I'd like to extend my thanks to my colleagues for setting the stage so well. We've heard a comprehensive overview of Snowflake Openflow. We have dived deep into its architecture and even explored how it integrates seamlessly with streaming platforms like Kafka through that insightful demo. Building on that foundation, I'm Senthilkumar from Cittabase and now shift our focus towards what matters most to our business, the real world use case where Openflow delivers tangible value to our business. Many organizations, like the first thing will be on the database, the prime focus will be on the database ingestions, like where many organizations today rely on Snowflake for analytics and reporting, but their core transactional data still relies on operational database like Postgres, SQL Server, Oracle, or MySQL. Real challenge is getting this data into Snowflake fast enough to support real-time insight without relying on the batch jobs or complex ETL framework. This is where Openflow makes a significant difference. With its native CDC support, Openflow continuously monitors your source database of any changes, whether it's new records, updates, or deletes. It captures the changes as they happen, and they replicate them to the Snowflake almost instantly. Because Openflow is low code, setting this up doesn't require months of engineering. Almost similar to the analogy, like we have heard about, like, fill it, shut it, forget it, a popular advertising slogan for Hero Honda CD100, emphasizing its fuel efficiency and reliability. You here also, you define your source, target, and configure the CDC once and let the pipeline run continuously. That's the flexibility that Snowflake offers for database replication. Next use case will be on what if the data lies outside your organization in the form of third-party APIs. With Openflow's external API integration, you can connect directly to these external APIs to fetch data in real time and load it to Snowflake seamlessly. No need for custom scripts or any middleware. Just configure the API once and let Openflow handle the scheduling, retries, or data passing, whatever it may be. Leave it to Snowflake to handle, Snowflake Openflow to handle. Then, the most common use cases is the batch processing of structured and unstructured data, structured and semi-structured data. Organizations constantly receive data files like in the form of CSVs, Excel sheets, or JSONs from multiple sources. These files often land in SFTP folders, cloud buckets, or shares. Instead of relying on manual checks and custom scripts, Openflow steps in with smart, ready-to-use connectors. These connectors automatically detect new files no matter where they come from and pass them through transformation process that clean, structure, and validate the data. Once ready, the data flows directly into Snowflake accurately and on time. This means there's no delays, no manual intervention, just seamless automated integration. The next one is the data where most of the important data are buried in SharePoint, actually, lay hidden in SharePoint. Like in the form of a Word document or PDF or presentations across SharePoint libraries. With Openflow, we can connect directly to the SharePoint sites. It doesn't stop at just pulling the file. We use chunking process, an intelligent component that breaks down the large documents into manageable, meaningful pieces. These text chunks are transformed and loaded into Snowflake. Real magic happens when we index them using the Snowflake Cortex search services. This enables semantic search where users can ask natural language queries and get back the match chunk and metadata about where the chunks are stored, enabling easy navigation to source documents. The last and the final one is what Azar already showcased a very great demo on the streaming data ingestion, which is the efficient use cases. Imagine your business getting data every second. It's like people placing orders or machine sending updates or users clicking on the app. Instead of waiting for a daily report, streaming topic ingestion lets you capture the data live as it happens. With Openflow, this real-time data can flow straight into Snowflake tables where it's cleaned up and ready to use instantly. So whether you're watching your fraud or tracking customer behavior or monitoring performance, you're always seeing the latest picture, not yesterday's news. It's like having a live news feed for your business data. Next. Imagine, sorry, to wrap it up, so Snowflake Openflow is more than just a pipeline framework. It's a modern data movement engine that transforms how organizations ingest, integrate, and activate data across systems in real time. Whether it's replicating databases, streaming events, processing files, or calling APIs, Openflow simplifies the complexity behind the scenes. The ability to react in real time isn't a luxury, it's a competitive advantage. Openflow helps you unlock that. So if you're curious about what Openflow can really do, please, a blog series is your guided tool from setting up real-time application to streaming Kafka into Snowflake to automating file ingestion the right way. Each post is hands-on, connector-focused. And we're just getting started. More blogs, more connectors, more automation patterns are on the way. Thank you for the time. And now I'll leave this to Krishnan to take over.
Thank you, Senthil, and thank you, team. Let's move on to the next slide. Again, thanks, team, for the great walkthrough. I think that was a solid overview of where Openflow is heading and why it matters as well. So I'd like to just take a moment to introduce you to something that we are really excited about. Part of our LeapSnow bundle, we are now offering an Openflow discovery and assessment service. So with Snowflake announcing Openflow at Summit 2025, the obvious question many teams are asking is, where do we start? That's exactly what LeapSnow is designed to answer. This isn't just a checklist. LeapSnow is a guided journey. We kind of help you make sense of your current data setup, assess your readiness for Openflow, and then identify where automation can have the biggest impact. We kind of dig into your architecture and workflows with a sharp eye on scalability, governance, and security as well. And we just don't do it silent, right? Our approach is highly collaborative. We roll up our sleeves, sit with your team for hands-on sessions, and give you a clear, practical documentation that you can carry forward as well. So once you're ready, we go a step further. We help you pilot the migration of one data source to Snowflake and enable Openflow pipelines that can handle everything, structured, unstructured, batch, streaming, etc. And all powered by Snowflake's native platform and built with out-of-box connectors to get you up and running faster. So think of Openflow as as your LeapSnow as your ramp up to Openflow, right? So it is kind of a practical, proven, and built to get results quickly and confidently. So we are kind of excited about what's possible with Openflow, and even more excited to help you realize that potential. So thank you again for joining us, and we look forward to continuing the conversation. Thanks, team, again for this great walkthrough and setting the stage well for our continued experimentation and work on Openflow. Thank you so much, all. Bye-bye.